Hello there, ROS developers, and welcome to this live class number 109, where we are going to talk about the real robot lab and how to change or how to switch from a simulated environment to a real environment with a real robot. So let's go for it. Hello again, hello there all of you ROS developers, and welcome to this live class number 109. So as I have just said, today we have a very special live class because we are going to be doing something that we don't usually do, which is to work with a real robot. So we are going to be testing this real robot lab that we have just launched some days ago and seeing how it works, how to create code for testing, how to switch from the simulated environment to the real robot environment, and a little bit how to do all of this, how to deal with it, and how to work with it. So let's go for it. I hope you enjoy this live class and you have a great time. And yeah, so let's go for it. Then let me know, guys, if everything is fine, sound is good, and image is fine. Let me just know if everything is good so that we can keep going. All good. All right, so hello there, Engineering Nations, Estrella, Montero, Tremont, Wes Dotremont, good here. Sorry for the pronunciation of your names. Probably it's horrible, but I don't know exactly how to do it. Okay, great. So everything is fine. Then let's go for it. So this is a live class. I don't know. I can see some names here that sound pretty new to me. Some others, I already know them from many live classes, but let me know if you are guys new in these live classes, if not. So we are going to be working today, we are going to do a little bit special live class because we are going to be working with a real robot. However, the structure is going to be the same. Yeah, so we are going to be working with a project. I'm going to share with you the project and yeah, so we are going to start as a regular live class, so don't panic because the structure is going to be the same. We are going to see that at the end. Maybe we are going to have some different things. Okay, I can see here many new people. I'm newbie. Okay, so welcome everybody. I hope you enjoy this live class. Then yeah, so as I have said, well, in fact, let's go for it. Let's not lose any more time and let's go for it. So I'm going to switch right now to my computer screen. So right here, I am in the construct main page. Yes, you can access here. Let me share with you guys here. Well, it's basically this link. Probably you already know us from previous live classes, or if not, you have came here, so you have also the link in the description if I'm not wrong. So for the new ones, you need to come here and create a free account here. It's going to take you a few seconds. It's completely free, so just create an account here and log in so that you come to this dashboard page, to this main page. This is the main page of the construct where we have all our we have the Ignite Academy and the ROS Development Studio, basically, which are our two main tools. In the Academy, you are going to find all the courses and everything. You can come here and find all the courses. Many courses of different topics. You can see here some TFs, ROS2 even, ROS Basics, both in Python and C++, Python 3, basic maths, Kalman filter. These are some robotics theory courses. Well, many courses which aim is to teach ROS and robotics in general also. And then down here we have the ROS Development Studio, which in fact we used it for the first time last week. So last week live class was the first live class that we did in our new ROS Development Studio. Yeah, so we have updated our old ROS Development Studio, and now we have everything in one single platform, as you can see, both the Academy and the Development Studio. So here in my ROSject section, I can see the ROSjects that I have here, I have been creating, working with. Yes, so here I can see the ROSject for last week's live class number 108, and here I have the ROSject for today's live class, 109. Yes, so what I am going to do right now is to come here to the project I have been creating. I'm going to come here to the ROSject page, and I'm going to click on the share button. Yes, then I'm going to copy this link here and paste it to the chat. So let me do it right now. Here I have pasted it into the chat. So here you have the link. Then what is going to happen? Well, once you are logged into the construct, you can click on this button, you can directly click it, you can copy paste it into your URL, and then you are going to receive into your workspace, into your My ROSject section, you are going to receive this same ROSject that I have here. Yes, so I have just shared with you guys a complete ROS project with a simple click. So that's how live classes work. Okay, then the next step we are going to do is to open this ROSject. What is a ROSject for all the new ones? Well, a ROSject is basically a ROS project. Yes, it has a machine with Ubuntu installed, ROS installed, and I have been doing some works there, creating some files, etc. And then I encapsulate everything, let's say, into a ROSject, and I share it with you so that you have exactly the same environment and setup that I have been working with, and that I'm going to be working with today during this live class. Yeah? Then the next step, guys, once you have the ROSject here, is to click on the Run button, and this is going to start opening here the ROS project. Yes, so by default it's going to load here a Jupyter notebook, which you are going to see that contains the instructions for today's live class. This is opened by default. It might take some seconds. So far so good, guys. Are you lost already, or are you following correctly? Have you been able to copy the ROSject? Are you opening it? Let me know. Lost, says Space Robotics. Thanks. Following. So where did you get lost, Space Robotics? Let me know. Let me know, please. Let me know, guys, because a very important part for me here in live classes is that all of us are on the same page and all of us can work together at the same time. Okay, how you loading ROSject? Okay, so here from the dashboard, this means here from the dashboard, yes, you can come here to the left side, and you're going to see at the top here you have the Robotic Ignite Academy with all the courses, and down here you have the ROS Development Studio. Yes, then inside the ROS Development Studio you have the option My ROSjects. Yes. You can come here to My ROSjects, and here you are going to have your ROSjects. Yes, so if you have just created your account, you are not going to have any ROSject here. That's normal. However, I have just shared here in the chat I have shared a link here to the project for today's live class. Yes, I have shared it here in the chat of this live. Yes, then by clicking on this link I have shared here in the chat, or by copy pasting it into your URL, whatever, by doing that you are going to get this project into your workspace. So you are going to also see this project here. Then in order to open it, you just have to click here and run. You click here on the run button on the project, and this is going to open your project. Yeah? Make sense? Then, as I have said previously, this is going to automatically open for you guys this Jupyter notebook with the instructions for today's live class 109. Yeah? So at this point you should be here with the project open it, and the Jupyter notebook as well here open it, prepared to start following and completing all these instructions that we have here. Yep. Okay, let me see here. I've opened it, all okay here. It says 502. Okay, it is working now. Yes. Okay, so Express Robotics, it's on the page. Okay, yeah, in case you get some strange 502 errors or whatever, just try to wait some seconds. Sometimes it's just a matter of patience. Sometimes, if not, you can try to reload the pages like this, clicking on these reload buttons. That might also help in some cases. Just keep in mind that this is still a beta version, yes, so we are still working a lot on it. We are doing many improvements to the platform, and we are going to keep doing it in the following days, weeks, and months. So some bugs may appear. However, it should be minor bugs, yeah, so nothing too big. Then keep that in mind only. So great, so we are all here with the project opened, and then one of these new tools that I was talking about is this Real Robot Lab, which we are calling RoBox. Yes, is this RoBox. By the way, let me share with you the link here to this page, which is the one we are going to be working with today. Well, we are going to be working with this tool today, so let me share this link here in the chat. Also, where do I have the chat? Here. Yes, so this link is going to take you to this page, which is the page for RoBox. What is RoBox? Well, RoBox basically is the first 24/7 ROS remote real robot lab. So what does this mean? This means that we have created here in our facilities, we have created a lab, an environment with a real robot, which you can see here in the video of the background, which is working 24/7. It's working with ROS, and you can connect to it from anywhere in the world. Yes? So this is basically RoBox. Then this is the tool that we are going to be working with today. We are going to be using today, so that you have a glimpse of what it looks and how it feels to work with it. Then so during this week, and I think as well a couple of days in the next week, I'm not sure. Well, we have here the countdown. So for the following 5 days, you can book dates for testing the Real Robot Lab, this RoBox. You can book time schedules for free. Yes, so for the next 5 days, you can book for free. I'm going to show you now how to do this and everything, so don't worry. Yes, so yeah, here you can check a video, super interesting, of what it looks like. In fact, you are going to see it live now, so you can check it later if you want, but you can get here many information in case you want to check it later after this live class, to see what you can do here, how it works more or less. In case you have any doubts after this live class, also you can come here and have a look. Yeah. Then yeah. So let's go for it. Then let's stop talking and let's start with the practice. Then RoBox Quick Start Guide. So here we have some instructions on how to start working with RoBox. So first of all, we need to start with a simulation, right? Because we are going to be working on a real environment. But before testing any code in a real environment, it's always a good practice to test the code in a simulated environment. Why? Because you can see expected behaviors of your robot, you can avoid crashing things, you can do many modifications into the code without worrying if the robot is going to break, it's going to break something, whatever. Yes? Then the idea of this is to work with a simulated environment which replicates the real robot lab. Yes? Then we are going to create our codes, we are going to test our codes into this RoBox simulation, into the simulated environment. Then once we are happy enough with the code we have created, once we think it's working properly, it's robust enough, then and only then we can go and test it into the real environment using the RoBox tool. Yeah? Makes sense? So here, if we come here for a moment to the home page, here you are going to see this Real Robot Lab tab here at the top, and you can come here and check it out live. So this is a live streaming of right now. Yes, in our facilities. This is the lab. So you can see it's a small here road, let's say, with some traffic signals, and here we have the Turtlebot 3 robot laying here in the middle. Yep. Then yeah, so as I've said, this is the real environment, but the idea, our goal would be to replicate something like this in a simulation, right? So that we can test it in a simulated environment before actually testing the code in the real robot. So here we can see some hands here which are saluting us. My colleagues here. Okay, yes, then so the first step is going to be to start the RoBox simulation, right? Then in order to do this, how we can do it? Well, we are going to start by opening a web shell. Yes, here in the left bottom corner we have the web shell tools. Here we have all the tools. Down here we have the web shells, the code editor, the Jupyter notebook, the gazebo simulation, graphical tools, Real Robot Lab streaming, and here we have the Real Robot Lab tool, which we are going to use later to connect to the robot. Yes, but let's go part by part. Let's start opening a new web shell here. Real Robot Lab session has finished. Okay. Yeah, so I have booked 2 sessions, one for the beginning of the class and one for the end. The one for the beginning has ended, okay, so we are going to be using the next one. Here now, as you can see, this button here has turned to orange, and it's telling me my bookings. I have a booking for 18:30 here, so for 6:30 p.m. in Barcelona time, yes, which is in 5 minutes. Is going to start my next session. Yes, I can see it here. However, let's forget about this for now. Then start the simulation. So we have here the web shell, and in order to start the simulation, we can execute these simple commands here. Yes, you can copy them from the notebook, copy and paste it. Let's come here to the simulation workspace. Let's source here this workspace. Let me make this a bit bigger. And then we can execute the ROS launch command, which is actually going to start the simulation. Yes, so once I have executed the ROS launch command, I can come here to the gazebo button, which is this one. As you can see, it's indicated here in the notebook. I can click here, and this is going to open for me the gazebo window, which it's going to show the simulation. There we go. Yes, so here it has loaded the gazebo simulation of the Real Robot Lab. Yeah, So as you can see, this is a replica. Yes, it's a replica of the real environment. Yes, we have the Turtlebot robot here with all the traffic signals, the road here. We have even some persons. If we zoom here, you can see some persons here, which actually we also have here in the environment, as you can see here. Here we have one person, here another. Yes, so basically this is a gazebo simulation which replicates. Yes, it's a copy, let's say, of the real environment. Yes, of the real environment that we have here. Then this is super important for testing. Yes, because the more exact the simulation is, the better is going to work later your code in the real world. Yes, makes sense? So this is called the real world gap, let's say, because there is always going to be a gap between a simulated environment and a real environment. Yes, because it's impossible to take into account all the variables that take place, that interact in a real environment. Yes, however, we can try to minimize this gap between the simulated environment and the real world. Yes, so this is a very important step here to try to have a simulation as similar as possible to the real environment. This is what we have basically here. Then, once we have our simulated environment, now we can start creating or testing our code. Yes, or creating our code, the code that we are interested in testing, right? So, let's now create some code in the simulated environment. Yeah, so this is what we are going to do right now. Then let's minimize this. This shell is where the simulation is running. So let's just minimize it and forget about it. Don't close it. Yes, because if you close it, the simulation is going to crash. Just minimize it, because we are not going to be using it anymore. And then let's come here and open a new shell. Yes, then here what we are going to do is to create our code. Then for this, we're going to have a command here in order to create a ROS package. So the first thing is that we are going to create a new ROS package here in our project, which we are going to name lab tests. Yes, so let me come here to the Catkin workspace, SRC folder, and paste this command. Catkin create package, lab tests. This is the name of the package I'm giving to the package, and I'm adding ROSPy as dependency. Yes, so that my package depends in ROSPy because I'm going to be creating Python code. Now let me create this program here. Excellent. I have created it. I can check it here in the shell. However, for developers, it's always better to develop and manage and navigate through your files in a graphical way, right? Therefore, what we are going to do now is to open here the code editor. Yes, next to the shells here option, we have the code editor. So let me click on the code editor, and this is going to open here my development environment where I'm going to be able to see all my files, etc. Let me make this a bit smaller. There we go. Yes, so here I can see all the workspaces. Right now we are working on the Catkin workspace. So if I open here the Catkin workspace, I'm going to see that my package has been created here, right? So I can see here my lab tests package. Let me reorganize this a little bit. There we go. Yep, so this is the package I have just created. Then next step, let's create a Python script. So let me come here to the SRC folder and create a new file. In this case, I'm going to name it like this, movement.py. Yeah, so new file, movement.py. There we go. And inside this file, I'm going to copy the code you have here in the notebook. Yes? Let's copy it from the notebook and paste it to our file. Yep. Then once we have this, all we have to do is to run our code. We can run it with the run command, and we are going to start seeing what this code does. Yes. However, before doing this, let's do a quick analysis here of the code. So let's see what this code contains, what to expect from this code. Yes. So let me let me tell you, this is a simple code I created, which goal is to make the robot do a movement, a kind of controlled movement, but it has many books. Yes, it has many things that could be improved in the code. We will see it during the class, which I would like you to improve it. Yes, so this code has many mistakes. You are going to see now reviewing it and when we execute it. So my intention is that you take this code and improve it, yes, make it better, and once you have created a better code, a more robust version of this code, you test it into the real robot, yes? So you book a session and you test your code into the real robot as well, yes? As I have said before, for the next following 5 days, the bookings are free, so you can book a session. Each session is for 30 minutes, so you can book a session for connecting to the real robot and test your code. Yep. So basically the main goal of this code is to make the robot more or less keep doing laps here in loop, yes, to keep going doing loops here into the circuit more or less. Yes, but let's check this. So here we have a class robot control. Well, basically we are initializing everything here in the constructor. We are creating a publisher for the command bell topic, a subscriber for the scan topic, and a subscriber for the ODOM topic, which the data from these topics we are going to be using it into this program. We are initiating some variables, messages, etc. Yeah. Here we have a helper function, the publish once in command bell, which basically allows to publish only one message into a topic. Here we have a shutdown hook, so that when we close the program, the robot stops. As you can see, we are setting here the velocities to 0. We have the laser callback here. We are storing the message that comes from the laser of the robot. Well, first of all, one thing we can do is to check and verify that these topics actually exist. So this we can do it easily, very easily, here from the shell, doing a ROS topic list. And we can see here that we have the scan topic, which is the topic that contains the data from the laser, from the scanner of the robot. We can also see here the ODOM topic, which contains odometry data. And we can see as well here the command bell topic, which is the topic where to publish in order to move the robot, to move the wheels of the robot, right? Then we can see these two topics actually are here in this simulation. We have the shutdown hook, laser callback, ODOM callback, where we are storing the odometry information, and also we are transforming this information from quaternion format to Euler angles, as you can see here. Here we are getting the front laser, so we are getting the information of the laser, which is from the front of the robot. Yeah, the robot is now looking in this direction, to this direction. So basically in this function get front laser, we are getting the laser beams that go in the direction, in this direction in front of the robot, right? Get laser full, here I'm getting the full data of the laser. Again, here we have a function, another helper function named stop robot, which is used to stop the robot. A function named move straight, which basically is going to move the robot straight at this velocity 0.03. This is important. This is actually important because there are some velocity limits into the real environment. Yes, so if we come here to the notebook, let's do it right now. If you come down here into the notebook, you are going to see here a section in orange. Here we have it. Yes, so be careful to not exceed a linear speed of 0.19 and angular speed of 0.49, because otherwise the node will be terminated due to security reasons. Yes, so we have to take this into account to not exceed some speeds. In this case, what we can do, for instance, is to set here some global variables, for instance, Vx limit, and VZ limit. And the BX limit we can set it to let's say what value did we have here? 003. Okay, so let's set this to 003, and the Z limit, let's set it to where do we have here the rotation? Well, the Z limit, maybe we can set it to 0, I think it was 0.49, or let's set it to 0.45. Okay, and then for instance we can use this global variable here to set the speed here, which is going to ensure that we don't pass this speed. Yes, why this is important? Well, because well, it's not good for either for your tests or for us to make the robot here, put the robot running like if it was a race car, an F1 car, you know. So there are some limits that we have to take into account, and the velocity limits are very important limits to take into account when you create your programs. Yes, so take this into account. Then let's keep going, because we were analyzing the move straight function, which basically, as we can see, it sets a linear velocity for the x-axis and it publishes the message. And then finally we have this rotate function, which basically reads here, it gets an angle in degrees and it makes the robot turn that specific angle. Yes? Then finally down here we have the main function, which is super simple. As you can see, we are initiating a ROS node, we are creating an object of the class. Then the logic, I made it here super simple so that you can improve it. Yes. Then here basically, while the program is running, what we are doing is to read the data from the laser in front of the robot. Yes. So in the direction that the robot is moving, we are getting the laser data. Yes. Why? Well, in order to get the value, which is going to tell us the distance from the robot to an obstacle. Yes. So we are reading here the you are reading here so you are getting the data from the front of the laser. Yes. Then we analyze this data. In case this value is lower than a threshold, which in this case it's 0.45 meters or 45 centimeters, yes, in case this value from the front of the laser gets lower, well, in case it is higher than this threshold, we are going to keep moving the robot forward and updating, of course, the front laser value. Now, in case this value gets lower than this threshold, which means that the robot is getting near, yes, it's getting close to some kind of obstacle, then in this case what we are going to do is to stop the robot and make it rotate. Yes, in this case we are going to rotate 90 degrees to the right. Yes, there is something to take into account in this simulation. As you can see, it has some default movements here. The robot is rotating. This is due to some issues that there are still in the frictions of the wheels. Yes. However, don't worry. In case this happens, you just need to. You can execute this command: ROS service call gazebo reset world. Yes, and this is going to reset the robot to its initial position. Yes. So the expected behavior in this case here is that the robot will start. Well, this keeps moving here. Let me. Yeah, it's not. As you can see, it's not moving because of the command belt topic, but it's moving because of the frictions. Yeah. So let me reset here the simulation. There we go. It shouldn't move now. Okay. Then the expected behavior is that the robot will start moving forward, right? So the robot should start moving forward here in this direction, right? In this direction. Then, meanwhile the robot is moving, it's going to keep tracking the distance between the laser and any obstacle in front of the robot. Then, once this distance gets lower than 45 centimeters, the robot is going to stop and it's going to rotate 90 degrees to the right. Then it's going to keep moving forward until, again, the distance from the front of the robot gets lower than 45 centimeters, and then it's going to turn again and keep going. Yes? So this is the expected behavior of the program. However, as you are going to see right now, there are many bugs in this program. There are many things that can be improved. For instance, this rotate function can be improved in many ways. Also, for moving straight, we are not tracking anything. We are not tracking odometry. So we are not making sure that actually we are moving straight. We are just setting here a velocity for the linear x value, but actually we are not making sure that we are moving straight. So there are going to be deviations, etc., etc., etc. Yes? However, the idea is this one. Then let's try to run the program and see what happens. So let me come here. Let me reset one more time the simulation, by the way. There we go. And there's one more thing that we need to do. Come here to the lab tests, SRC folder, and make sure that your program has execution permissions. Yes? You can do this with the following command: chmod +x movement.py. Yes, so now we are going to see that the file has execution permissions. Then let's source our Catkin workspace and let's run our program. ROS run lab tests movement.py. So I'm going to run my program, and as we can see, the robot starts moving forward. You can see here in the simulation, my robot is moving forward. Then I should expect that somewhere around here the robot stops and turns 90 degrees to the right. There we go, it stops, it turns 90 degrees to the right. And it keeps going. There we have it. Yeah? So it keeps moving forward. So now the distance from the laser to the obstacle is higher than 45 centimeters, so the robot keeps moving forward. Then once this distance gets lower than 45 centimeters, the robot is going to stop and rotate 90 degrees to the right. Yep, makes sense? Then here, as you can see, it has rotated 90 degrees to the right, but it has done the turn from the other side. Yeah, so it has taken the long way. However, the turn is the same, but instead of doing the easy turn, which is turning to the right, it has turned to the left side. Yeah, so this is something that can be improved for sure. Here, what it has happened is that it has detected this, right? It has detected this obstacle and then it's turning. Yes? So actually, here we should have made it turn before, so that it comes in this direction. Yes? So well, in any case, you have seen the idea. Many improvements can be done into this project, into this code, and I am going to let that to you to check the code, test it, and improve it with your own code. So now what I'm going to do is to stop the robot here, stop the program. Now we have seen this in the simulation, so now let's test it into the real robot. What do you say? Because we have seen this program working here in the simulation, so now I would like to test it here in the real environment and with the real robot. So for doing this, I have added the instructions here as well. Yes, However, it's super simple. Yeah. Well, the first thing you would need to do is to book a session. Yes, you can do here in the main page in the Real Robot Lab section. Here you can come here and you can select here to book a session. As you can see here, you can see the calendar. Book a session. You can choose the robot. Currently we only have the Turtlebot 3, but we are going to add more robots to the Real Robot Lab, to like manipulators, etc. But currently we only have the Turtlebot 3. Then here you can select the day you want, the schedule, the time you want to reservate. You click on continue and it's going to reservate the time for you. Yes? Makes sense? So super easy. Then in my case I already have my reservation done. As you can see, I have 7 minutes left, so I must hurry in order to connect, because in 7 minutes I'm going to lose my connection. Yes? Then, one thing to note, as you can see here, well, it's specified here. Well, as you can see also, this has appeared here. So when you are in a session, this button is going to appear here in your project, and this is going to allow you to open a window here in order to visualize the real robot. Yes? Then, we are going to click here in order to visualize the real environment. Then one thing to note is that when we connect with the real robot, all the shells and everything is going to be killed. Yes, because we cannot be working at the same time simultaneously in the simulation and in the real robot. So the simulation and the shells will be killed. Yes, this is as well explained here in the notebook. If I'm not wrong. Well, it's indicated somewhere here, but I'm just telling you that once you connect with the real robot, everything will be closed. Yes? So, let's close this for now. Let's close this. You are going to see also that the simulation, the shell where we have the simulation is going to be closed and everything. So, for now, let me just come here and click on the turn on option. Here, turn on off. So by turning on, I'm going to connect to the real robot. So as you can see, all the shells, all my shells have been closed. My web shell is loading now. It's going to let me open new shells in just a moment. I need to wait until this reloads. And now I can again open a new shell. Now this shell that I have just opened is now connected to the real robot. Yeah? So now if I do a ROS topic list, I'm going to be connected to the real robot. So all these topics I am seeing here are from the real robot. Yes? So maybe you don't trust me here. Okay, I get it. But let me show you, in fact. So one thing we can do here is to start moving. Well, first of all, what I'm going to do is to open RVs. Yes, so what better tool in order to verify this than RVs? Then, okay, so I'm going to open the graphical tools in order to be able to visualize RVs. There we go. Here we are connected to the real robot. And now what I can do here is, for instance, to add a image. An image display, and select the topic for the image raw. Then this is going to show me what the real robot is actually seeing. So let's wait a few seconds until the image loads. It might take some seconds. Let's see. This is taking more time than expected, by the way. Maybe it's because I am in front of a wall and I am reading a wall. Could that be possible? Actually, yes, because if, as you can see, the robot is right in front of a wall. So maybe what I am seeing actually is the wall. Now let's try one thing. Let's open another shell and let's try to move the robot. No, creo que está bien. Creo que es la pared. Se puede alargar un poco el tiempo, ¿no? Porque es que quedan 3 minutos. Okay, we have only 3 minutes, so let's try to hurry here because otherwise we're not going to be able to test all this. Then, okay, so let's try one thing here. Here in the notebook as well, we can see the instructions here in order to launch a teleop keyboard program. Yes, so for this we can export the Turtlebot 3 mother variable and we can ROS launch this command. ROS launch Turtlebot 3 teleop k.launch, right? Then this is going to launch a program which is going to allow us to control the robot with the AWSD gaming keys. Yes, so let's try this. Yeah, so as you can see here, my colleagues have moved manually the robot, and now we can see the real environment. So what we are going to do now is to let me make this a bit bigger here. Yes, put this here in this side. I'm going to put here in this side RVs. Let me put this here. Too many shells, right? Let me organize this. Okay, I'm going to put this here, this up here, and the project right here. Actually, I'm going to minimize this. What is this? Okay, yeah, here I have RVs. Then now I'm going to start moving the robot. So what I should see is how these obstacles start changing. Yes, I'm going to start rotating the robot and I'm going to see the movement with a little bit of delay. Yes, there are some seconds of delay in the camera. So we are going to see first how RV's camera updates and then we are going to see the robot moving later. So let me start here rotating a little bit the robot. Yes, actually this is not. So the robot is not moving for some reason. Let me see. I don't know really if it's not moving or if it's this which is RVs that is freezed. Let me take this out and load it again.
Sí, está ok, pero no sé por qué no se mueve.
Right.
Todo está ok.
Okay, so well, Real Robot Lab session has finished. Okay, yeah, so actually I think the robot was not actually there moving, I don't know, so the topics were there, everything was there, but for some reason it was not moving, I don't know. In any case, we are going to check this right now to see why it was not actually moving. So actually we didn't have time, which is a pity, to test our code, the code we created here, but well, maybe we can do it in a future live class, or maybe you can do it directly yourselves. Yes, in any case, there was some strange error here with the robot not moving. I don't know exactly what it was. We are going to check it now, and don't worry, because we are going to solve it and you are going to have it working for the next days, so that you can access, you can book your sessions and you can test your code with the real robot. Yes.
¿Tienes reservada la siguiente sesión?
No.
Se te acaba el tiempo. Se te acaba el tiempo, por eso ya no está el manager matando todo.
Ah, okay. So my colleagues are telling me that actually what has happened is that my session, my real Robot Lab session was finished, and during the last minute or so, basically what happens is that all the managers and everything in the robot start being killed. Yes, all the programs that run the robot start being killed. So that's why at the end I couldn't do nothing. Yeah, so this is my bad. I should have booked for some more time. I actually didn't thought that I was going to be so short in time. But unfortunately, I don't have the next hour booked. Actually, we have some user that has it booked, so I cannot actually test it now. However, so yeah, basically there's no problem. Then, as I have just said, you can book sessions. You can come here. You can book them directly from the page. You can book them here from our Real Robot Lab. You can come here, select the time you want to test it, and book it. Yes? And my suggestion, as we have been doing during this live class, is to first test your program here in the simulated environment, as we have just done, and once you have it tested, then just try it and test it in the Real Robot Lab. Yeah, so as you have seen, you are going to have sessions of only 30 minutes, and time flies, as you have seen in my case, especially. So take this into account and make sure to have everything ready before you go to test it into the real robot. So for the next 5 days, you can book sessions for free. So I really encourage you to do so, to try it, to test it. And yeah, you can create, you can record your sessions, what your scripts are doing. You can share it with us. Hey, Alberto, I have created a program which detects the stop signals and then it stops the robot, for instance. And then you can test this program in this simulation, test it in the real environment, and you can record a video of how your program performs here in the real robot. Share it with us. That would be amazing. But basically, yes. So let me have a quick look at the chat here. Okay, excellent, says Space Robotics. Yeah, so this is amazing for sure, says Lucas Vargas. Thank you very much, Lucas. Yeah, we also think it's amazing. It's a very new tool, so take this also into account. It's super new. We just put this live some days ago, so some bugs may still appear. Please take this into account. Bear this in mind. We have done many tests and it's working super nice. So we are pretty confident that everything is going to work well, but in any case, there might be still some issues. Some issues might appear because of this, because it's super new and it's still on a beta version. Yes, but yeah, try it. Yes. So what a better way to see how it works than try it yourself? You can try it completely free. Yes, for the following 5 weeks, and booking a session for the following 5 days, you can try it for free. So what a better way to check it and to test it and see how it works than trying it yourselves. Yeah? Felipe is asking, hello Alberto, what are the dimensions of the circuit of the robot? I don't know now exactly, but probably my colleagues can answer that question in the chat, because they know exactly the dimensions of the circuit. And yeah, guys, so thank you very much for this live class. I hope you have liked it. I hope you have enjoyed it and that you are willing to try this new tool, this RoBox tool that we have created for you. So yeah, thank you very much. I hope to receive many videos from you. Can we, the free users, also give this a try? Yes, Danny, yes, you can. So as I have just said, for the following 5 days, you can try it for free. You can try this tool for free for the following 5 days. Yes. So guys, do it and record your screens while you are doing it and share with us what results you get. That would be amazing. Yeah. So yes, guys, let me change again my screen. Thank you very much for this live class. I hope you have enjoyed this hour and this tool. I hope all of you are willing to try it by yourselves and see how it works and to test your codes to see to be able to test the programs you create with the real robot. And yeah, so thank you very much. I will see you in the next live class, and until then, keep pushing your ROS learning. Bye bye. What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have this same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.